Hey, we have here another integral today. This one's from MIT Integration B 2010, problem 14. We have the integral from 0 to 1, x to the 13 over 2, square root of 1 plus x to the 5 over 2 dx. Okay, so this is going to be the last integral from MIT 2010. I kind of put this one off as I had a few dilemmas and problems. And I think before we get into the integral, let's just go over the issues I had and see and also if anyone can help me out in the comments, let me know. So the first issue is that I ended up with a different answer than MIT. I'm pretty sure I have the right answer, but feel free to let me know if there's some logic to why I got a different answer or if you got a different answer. I did find my method to be a little long and tedious, so let me know if you found a shorter way or something to kind of clean this up a little bit. Okay, so to get started, I'm just going to do a use substitution of what we have in the radical, and I'm doing that to simplify this piece, and hopefully things will combine a little better. Okay, so if this is our value of u, I also want to solve for x. So let's see, I'm going to say x, we'll say x of 5/2 is going to be u minus 1. And then if we square this, we can say x to the 5th equals u minus 1 squared. And this is going to be the same thing as u squared minus 2u plus 1. And then I think I'll just get my derivative here. We could get it from over here, but let's get the derivative here. So du is going to be 5/2 x to the 3/2 dx. And then before I substitute, I'm actually just going to rearrange the integral. So how I'm going to do this, I'm going to create my du part over here at the end, just to make it clear. So we'll have our 5x 3/2 dx here. Then out front here, we'll have 2/5 x to the 5th. And this is the same thing as 10/2. So noticing if we multiply 2/5 times 5/2, we have 1, the 1 here. And then x to the 10/2 times x to the 3/2 gives us our x to the 13/2. So then I'll make my substitution. We'll plug a 1 in here. So for our upper bound, we'll have 2. Plugging a 0 in, lower bound, we have 1. And actually, I'm going to take this 2/5 out front of the integral. So x to the 5th, we have this value. So we'll write this, u squared minus 2u plus 1. Then we'll have, this is just going to be u to the 1/2, or square root of u. And then this here is going to be our du. And then what I'll do is just multiply this right in here. Okay, so this is setting up, all I'm doing is setting up the power rule. So here we're gonna have, this is gonna be u to the 5/2 minus 2u 3/2, and then the last one's gonna be plus u to the 1/2 du. And then we'll just do the power rule here. So this is gonna be, we're gonna have u to the 7/2 here with a 2/7 in front. And then we're gonna have, well, our minus 2, u 5/2, 2/5 up front. And then the last one, we're going to have u 3/2, but we need to multiply by 2/3. And I don't really see a problem with this part. This is quick. I mean, you might be able to find a slight change, but I think the tedious part is actually just evaluating this. So I don't know, maybe it's not so bad. Okay, now from here, just for the simplification, I'm going to factor out a u to the 3. I'm going to actually factor out a 2 u to the 3/2. So what we'll have, now we're going to have a 4/5 in front and u to 3/2. Let's see how this simplifies. So now this is going to be a 1/7 u squared minus 2/5. And this is going to be just a u, and then this last piece is actually just going to be 1/3. Okay, now we'll just evaluate this, and first we'll start with the 2. So first we'll plug a 2 in here. 2 to the 3/2 is going to be the same. I'm going to write this as 2 square root of 2. Then plugging in here, we're going to have 2 squared is going to be 4/7. Minus 4/5 here, plus 1/3. Then next for our 1, we're going to have 4/5. 1 to the 3/2 is just 1, so we'll ignore that. Plugging a 1 in here, this is going to be very simple. 1/7 minus 2/5 plus 1/3. I can write this as 8/5 square root of 2. Now what I'm going to do on each of these, I'm going to get a common denominator. Multiplying all these together, my common denominator is going to be 105. So then doing that here, we'll have to multiply 15 times 4 is 60, 21 minus 4 is 84, 35 times 1 is going to be a plus 35. Then next again, all over 105, we're going to have 15 times 1, 21 times 2 is minus 42, 35 times 1 is a 35. If we add up this numerator, or add and subtract up this numerator, we're going to have 11/105 here. And then for this one, 15 plus 35, 50 minus 42 is 8/105. And then just to finish it off, I think what I'll do, we could do this a few different ways, but I think to finish it off, 5 times 105, we're going to have That's going to be 525 in the denominator here. And then multiplying in here, we're going to have, this is going to be 88 square root of 2 minus 4 times 8 is 32. And that's it. I did mention at the beginning of the video that MIT had something different. This is crazy. They had 7 over 30. So those two, that's not, I think their answer was just a typo. I don't know. I mean, I don't know how to avoid, I have a square root of 2, so I don't know how you could get I don't know how you get anything like that. I can't remember, I might have done the decimals and these might have been kind of close, but they weren't that close. So I'm saying they're wrong, but you can put it, let me know in the comments, maybe someone found this answer and I'll apologize. I'll issue an apology on YouTube. Anyway, thanks everyone for watching today and have a great day.